All right. Well, hi, everybody, and welcome to National Family Code Night. We are so glad to be with you here today, this evening. It's 3 o'clock here in California, 6 o'clock on the East Coast. And we have schools from all over the country joining us tonight. We're really happy to have you with us tonight. We've got from Florida, William Moseley Elementary School. From Maine, Harriet Beecher Stowe, who, as I recall, was actually from Maine, a wonderful author. And the Kate Furbish Elementary School. In New Jersey, the William Grove Elementary School. From Pennsylvania, great turnout, Chartier Valley Intermediate, Chartier Valley Primary School. Now I have trouble pronouncing this one, Conshohocken Elementary School. I hope I've got that right. And from Texas, we have the Greenwood Intermediate School. In Virginia, Stony Mill and Strawberry. West Virginia, we've got West Preston School, and I think we got some other schools along with us tonight too. So anyway, wonderful to have you here tonight for Family Code Night. We love doing these. It's a way that we can get together with children and parents from all over the country as part of our work. I'm John Pierce. I'm the director of Family Code Night, and our new organization, CS is Elementary. That stands for Computer Science for Elementary School Kids. And our mission is to try and bring computer science education to every school and every kid in the United States. Today, I'm really happy to be working, as always, with my partner, Julie Troy. Julie, want to say hi?
Hello there, everyone. As John said, my name is Julie Troy, and I'm helping out in the chats and with the YouTube live stream. So if you see the CS's Elementary chatting with you, that's actually me. So happy to have you here tonight. Happy to answer any questions that you have as we code tonight.
Fantastic. Thanks a lot, Julie, and we'll be back with you in just a little while, I am quite sure. All right, well, let's get to it here, everybody. So welcome to Family Code Night. We started a couple of years ago doing these events. It used to be a 1-hour event in school where parents and children got together at a school event. And, since COVID, we started doing it as a live stream, and that's what lets us talk to all of you all over the United States. So we're really happy to be with you here tonight. As I mentioned, we're now CS Elementary is our organization. And just as a quick side note, we just had a summit called CSK5. It was the first national summit ever for K-5 computer science education. And we had people from 40 states, leadership from 40 different states joining us at the summit to talk about the programs in their state for computer science education. And so if your state is one of these states that's lit up on our map here, and I know we have Pennsylvania and Virginia and Maine and a bunch of other states represented with us tonight, you can go to CS Elementary and you can, right up at the top of our webpage, you can click on View the Summit, and you can watch the video of your state's half-hour breakout session describing the K-5 computer science programs for children and schools in your state. So we were really excited to have that summit, and it really started this national movement for K-5 computer science education in every school. And parents, we're a parent-oriented organization, and on our website, you also see a way that you can ask your principal to bring more computer science for your school. So we'll talk about a little bit of that at the end of our program tonight. So let's get going. And before I say anything else, I want to say thank you to Infosys Foundation USA. They're our partners, and they support our work and have been our great partners for years. And also, I want to mention their Pathfinders Online Institute. That's an online website where you can find all kinds of classes and courses for computer science and maker education, for parents, for educators. It's just a wonderful site, and we have a lot of resources there too, including our Code 5 courses that we'll talk about a little later. So enough intro. What is Family Code Night? So here's what Family Code Night's all about. It's a chance for K-5 children to sit down with their parents and to pair up as a team and start to learn about coding and computer science. And if you've done coding and computer science before, great. If you haven't, that's fine too. And there's really just one thing that we want to teach you more than anything else tonight, and that's this. Kids, you can code. K-5 children are great at learning about computer science because you love screens, you love playing with screens, but it's interesting because when you code, it's actually very different than just watching a screen because you get to create what's happening on the screen. That's a lot more fun, and it's really valuable. It is fun. You can create animations, you can create computer games, you can program your own stories, all kinds of wonderful things you can do as you learn more and more about coding. It's really fun. But you know what else? it's also a way to really take care of your future, because almost any job that you do is going to involve coding and computer science and technology. And in fact, if you look at the jobs that are being added in the economy, there are far more jobs in computer and information technology, even than in the other areas of STEM, science, technology, engineering, and math, which is, such a hot area. Collectively, computer science and computer information technology jobs are by far the largest category, even within STEM. So that's why it's so important. That's why it's so much fun. What are we going to do tonight? Well, we're going to be using Hour of Code puzzles. And some of you kids, a lot of you kids may have done the Hour of Code before. We're using one set of the Hour of Code puzzles from code.org. And now, kids, if you've done these before, this is your chance to be the teacher for your parents. So be nice, have a good time, be patient. Your parents may take a little, time to come up the curve. I'm sure you'll be able to help them and you'll have a great time together. But in addition to the puzzles, we're going to learn 6 big ideas about computer science. We love the puzzles from code.org, the Hour of Code puzzles. And we can use them to teach these 6 big ideas. And so we're going to leave you tonight with 6 big ideas. And as we go through the puzzles together, you're going to learn those. And these are ideas that will stay with you forever. These are common to almost all computer science languages and coding languages. And then there is one more thing we're going to be doing tonight that's kind of fun. We're going to have a contest. We're going to have a prize drawing, and somebody is going to win a pretty cool prize. And we'll tell you a little more about that as we go. So that's the overview of the program. Now, we also have just something to explain about how the program works. Right now, we're sitting here in a Zoom meeting, and either here or in our YouTube live stream, you're watching me talk to you right now, and that's great. And in a few minutes, I'm going to ask you to open another tab in your browser, and in that tab, I'm going to ask you to go to these puzzles that we're going to be doing as we go through the program tonight. And then I'll ask you to do certain puzzles, 1 through 2 or 3 through 6, and then I'll ask you to come back here to this tab, to our live stream, where I'll talk to you some more, teach you the big ideas about computer science, and give you some hints about these puzzles, because they get a little trickier as we go along. But you're going to have a great time, and you're going to learn everything you need to know. So it's from this live stream here over to your browser tab, and then back to the live stream. We also have a few rules for our program tonight, and let me walk through these because these are important too. First, these are self-paced puzzles. What that means is when you get done with one puzzle, you're automatically taken to the next one, and you don't have to hurry. You can go at any speed you want. Don't worry about it. It's all good. Take your time, and it's not a race. Second, we'd like everybody to be in a 2-person pair if you possibly can, and ideally a parent and a child working together, because that's part of the fun of Family Code Night. Every pair should share one computer, and this is the hardest rule of all. You have to trade the keyboard back and forth with your partner after every puzzle. Now, a lot of times parents may want to sit back and watch their child do this fun stuff. And a lot of times kids don't want to give up the keyboard because they're having fun and they want to hold it. No. It's not the way Family Code Night works. You trade the keyboard back and forth after every puzzle. And then we even have a name for the 2 jobs. The person who has the keyboard is actually doing the coding, and we call that person the driver. And the person who doesn't have the keyboard, we call that person the navigator. And the navigator gives advice and ideas to the driver to solve each puzzle. And so you're working together as a team to figure out the logic of each puzzle. And you're going to need each other because, as I said, these puzzles do get a little trickier as you go along. So then after the puzzle's over, you trade jobs. The navigator becomes the driver becomes the navigator. And then the person who had the keyboard can't touch the keyboard, can only be an advisor. So that's the rule about trading the keyboard after every puzzle. Next, turn up the volume on your computer and set your browser to full screen. It's great to see these. There's cartoon characters and a lot of fun stuff on the screen. You want to see it big. So you're going to, in a minute, open a second browser tab for the puzzles, and then you're going to come back here to the live stream to join us for the 6 big ideas and the other information that we'll be giving you here. All right, I think we're about ready to dive in. And what we're going to do next is we're going to learn the programming language that you're going to be using to solve tonight's puzzles. It's called Blockly. And code.org, that created the puzzles we're using tonight, also created this really great little 2-minute video. It's going to show you about Blockly, and then you're going to know a lot more about how to solve these puzzles. So let me jump over to the little video. I'll show you this right now. I'll be back in 2 minutes. Watch closely. This is a nice little video. You'll like it.
I was in 8th grade when I learned to program.
I first learned how to make a green circle and a red square appear on the screen.
You just learn these lessons, and there aren't that many of them, and you just eventually can get to the point where you can do almost anything that you want.
computer science is just learning how a computer works and how it thinks so that you can teach it to do new things.
These days, what you can do in computer science is pretty much amazing.
I think it's the closest thing we have to a superpower.
In the next hour, we're going to play a game that will teach you the basic concepts of programming. Usually programming is all in text, but we'll use Blockly, which uses visual blocks that you drag and drop to write programs. Under the hood, you're still creating code. To start off, we're going to build code for a program that will help this angry bird move through a maze to get to the evil pigs that stole its eggs. Blockly is split into 3 main parts. On the left is the bird's maze, where your program will run. The instructions for each level are written below the maze. This middle area is the toolbox, and each of these blocks is a command that the bird can understand. The white space on the right is called the workspace, and this is where we'll build our program. If I drag the move block to our workspace and press run, what happens? The bird moves forward 1 box on the grid. And what if I want the bird to do something after the move forward on 1 box? I can add another block to our program. I'm going to choose the turn right block, and I'll drag it underneath my move block until the yellow arrow appears. And then I'll drop it, and the 2 blocks will snap together. When I press run again, the bird will perform the commands that are stacked from top to bottom on our workspace. If you ever want to delete a block, just remove it from the stack and drag it to the trash can. After you've hit run, you can always hit the reset button to get the bird back to the start. Now let's get those pigs.
All right, let's go get those pigs indeed. Now, and by the way, don't worry if you didn't remember everything about Blockly just from that little introduction there, because we are going to help you with a few tips along the way, and you are going to be just fine. Now, the next thing I want to do is to show you how to get to the puzzles that we're going to be using tonight. And what's going to happen is you're going to come to this page I'm about to show you. Don't go here now. I'll give you the URL to get here in just a second. But you're going to come to this page, our Family Code Night Start page. And you see this big link right up here at the top that says Start the Program. I'm going to click on that link and watch what happens. When I click on the link, it opens up a new tab. And the first thing that we see when the new tab opens up is a window that contains the movie that we just watched, that little 2-minute video. If you want, you're perfectly free to watch that again, but you sure don't have to. You can just click the little X up here and close that. We already went through that, and that will bring you to the first puzzle. Here's our first puzzle of the 20 that make up tonight's program. And here are a few little tips and hints that you'll see as you go. First, you're going to drag move blocks out and snap them into the other block. We saw that from the instructions in the video. You're going to hit run to run your program right here. That's great. And then at the top of every puzzle, there's this little line right here that gives you the instructions for what you're trying to do in that puzzle. So in this case, can you help me catch the naughty pig? Stack a couple of move forward blocks together and press run to help me get there. Okay, so here's our angry bird up here. And then here's the pig that stole his eggs down here. And so the angry bird has to go 2 blocks forward, 2 spaces forward to get down to the pig. And I think we saw in the puzzle before, you drag blocks out here and you snap them together. And when you think you have the puzzle right, or the program right, you click run to run your program. One thing to remember is the commands are always from the perspective of the bird. And that means right here, the bird is pointing down. And so when you say move forward, he's going to move down. If he was pointing over here to the right, then move forward to take him over to the right. So you always want to think about move forward or turn left or turn right from the position where the bird is and which way the bird is facing. So keep that in mind. One other tip I'd like to give you, and then I'm going to turn you loose and let you go and start these yourself. If you'd like to see the instructions for these puzzles in a language other than English, right down here at the bottom left of your screen, there's a pop-up that you can pick all kinds of different languages. You can see, I can't even pronounce all those languages, Dansk, Deutsch, Espanol, I know that one. And so you can pick any language you want and the directions will be displayed in your favorite language. Okay, so I think that that's about it for the moment. Now what I want to do is show you how to get to that first puzzle. And so what you're going to do is you're going to come here to the page we started on just a second ago, and let me show you the URL, that is the internet address to get to that page. It's familycodenight.org/start. So open a new tab in your browser, and in that new tab, enter familycodenight.org/start, and you'll remember where you're going to end up. you're going to come to this page right here, and you're going to click right there where it says start the program. Julie, can you drop the start link in the chat area there so everybody can just click on it?
Absolutely. I will do that right now.
All right, awesome. So you should be able to just go to the chat area in the live stream or here in the Zoom and click on the link. Or if you want, you can type it in manually, familycodenight.org/start. And once you do, you're going to go to that first puzzle that we all just looked at together. Again, you can watch the movie if you want to or not. And of course, on the way you get there is coming to the start page right here. And you'll click on the start the program link. And that is what will take you to the first puzzle. So that's about it. If you have any questions, you can drop them into the chat area. I know Julie will be happy to help you out over there. And we will see you when you get done with the first 2 puzzles. And then we're going to learn our first big idea in computer science. So I'd like you to do right now is I'm going to pause. You go ahead and complete puzzles number 1 and 2. It's only going to take you a couple of minutes. I'll be back in just a couple of minutes and we'll look at number 2 together and we'll learn our first big idea about computer science. So I'll see you in just a minute, everybody. All right, everybody, come on back to the live stream. We're going to take a look at puzzle number 2. I'm sure you guys have done this by now, but come on back. And I want to show you a couple more things, just a couple more tips. And we want to learn our first big idea about computer science. So, you already have done a couple of puzzles, so you know how to solve these. Here's our bird. The bird has to go forward. And again, he's facing to the right. So forward means 1, 2, 3 move forward blocks, because that's the direction he's pointing. Always put yourself in the position of the bird. So I'm going to drag out 1, 2, and there's my 3 move forward blocks. They're all connected. And now when I click run, pretty sure that's going to solve this puzzle. I bet you guys have already solved it. Let me show you a couple more things. If you want to move blocks that you've already brought out into the workspace, just grab the top block and you can move more than 1 block at a time. So if you want to throw away 3 blocks at once or something, you can grab all 3 at once. And if you want to throw blocks away, just drag them back into the blocks area. Let go and they disappear. So that's one little hint about that. As you go along, you'll notice that new blocks are going to appear down here that give you more and more power as a coder. And so as we go along, I'll explain what those blocks do. And they really make you teach you new things about coding and make it easier to solve all these puzzles. If you ever get stuck on a puzzle, you'll notice that the run button turns into a reset button. You can just click that button and that'll take you back to the beginning of this puzzle. So those are the main things to remember. I think I pushed the reset button and our bird started growling at us, didn't he? Not a problem. Hit reset. He'll go back and start again. All right. Very good. All right. That's it for the tips. I think it's time for us to learn our first big idea. Let's jump back over here. And our first big idea, well, it's pretty basic to coding, and it's a place we start in Family Code Night. What is a program? You know, when people talk about programs, they're talking about coding or software development, writing code. All of these things are about programming or coding. And what is a program anyway? Well, a program is just a list of instructions that you create to tell a computer what to do. And you know what? You've just written your first couple of programs, because when you stack those blocks up using Blockly, what are those blocks? They're a list of instructions that tell the computer what to do. So congratulations, you've learned your first big idea in computer science and you've written your first couple of programs. So nice job, everybody. Good going. And now what we'd like you to do, go ahead. I'm going to pause again. I'd like you to go back and complete puzzles number 3 through 6. And then we're going to get together at puzzle number 6, and we're going to learn 2 more big ideas about computer science. And also, as you're going along, let Julie know what puzzle you're on in the chat area. Just say, hey, we're on puzzle number 4, or we're on puzzle number 12, or whatever it might be, because that'll help us know when we should come back to do the next section. And by the way, I want to emphasize again, we have kindergartners with us tonight. We have 5th graders with us tonight. Some kids are super fast. Some kids have never seen or played with Blockly or coding before. So don't worry about how fast or slow you're going. It's all good. You're learning great stuff. You're doing a great job. So don't worry about racing or going fast. But do let us know what puzzle you're on, and we'll see you at puzzle number 6. See you in just a couple minutes, everybody.
Awesome. It looks like we have got some people on maybe as far as puzzle number 12. We've got some people maybe in puzzles 4 or 5 doing pretty good. And like John said, we've got kindergartners, we've got some 5th and 6th graders here. So if we go a little bit fast, don't worry. You can always come back and work at these on your own pace. If we're going a little bit too slow, you want to work ahead, also, hey, that's okay. But do come back and join us for some of these important little tidbits in between.
There we go. All right, good deal. Glad to know where everybody is, and thanks for letting us know, everybody. Keep us posted. All right, let's all come back to the live stream, and you'll see I've gone to puzzle number 6 here because we've got 2 big ideas that we're going to learn here at puzzle number 6, and they're pretty good ones. I like these. So here at puzzle number 6, you can see that a new block has been introduced, this repeat block down here. If you look at the puzzle, you've solved these puzzles, you know how this works. Our bird has to go 1, 2, 3, 4, 5 spaces to get to the pig. And we know how to do this. We just stack up 5 blocks. But, imagine if the pig was 100 blocks away. Imagine stacking up 100 blocks. Or imagine if the pig was 1,000,000 blocks away. That would take an awfully long time, wouldn't it? Well, that's the beauty of the repeat block. It makes you a much more powerful coder because you drag out the repeat block, and then any block you put inside the repeat block will repeat as many times as you tell it. So in this case, we know the bird has to do the move forward block 5 times to solve this puzzle. So we're going to take the move forward block, we're going to stick it inside the repeat loop, and there's our number 5 right there. That number could be 100, it could be 1,000, 10,000, 100,000, 1,000,000, it could be anything we want, although probably that would make our computer go crazy if we went that high, but let's go with 5. I think that's the right number. So this is a way that in just 2 blocks, the repeat block and the move forward block, we do the work of 5 blocks. So that's pretty powerful stuff. Let's run it and see what happens. Here we go, repeating 5 times. 1, 2, 3, and perfect. All right, so that's the way a repeat block works, and that is our second big idea in computer science. What is a repeat loop or a repeat block? Well, it's what we just learned. A repeat block repeats any block or blocks. You can put more than 1 block inside if you want to, as many times as you say. And so it has this effect of making you much more powerful as a coder. And this actually leads us to our third big idea in computer science that's really nicely illustrated by that same puzzle. It's called code efficiency. Now, it sounds like kind of a big technical word, but kids, don't worry about it. I'm going to show you. You're going to see exactly what this means. Let's go back and look at puzzle number 6 again. I'm going to click on replay to go back and play number 6 one more time. I'm going to click on reset to start the puzzle again. So here we are back at the beginning of number 6, and I'm also going to get rid of the blocks we already used last time. Now, you remember if we didn't have the repeat block, or if we didn't know how to use it, one way we could solve the puzzle would be to drag out enough move forward blocks to solve the puzzle. But I want to show you a little scoreboard that you get on every single puzzle that will show you how well you're doing solving this puzzle. At the top center of every puzzle, there are 2 numbers. The first number shows how many blocks you've used so far. Watch what happens when I drag out one more move forward block and connect it to our stack. Boom, and that number changed from 2 to 3, didn't it? Well, the second block tells you how many blocks you should be able to solve this puzzle in. Well, it says 3. So we should be able to solve this puzzle in 3 blocks. And you know what? We know we can do that because we just did it with the repeat block. So let's do it the old way for a second. And I want to show you what happens. If I drag out one more block, that is 1 block more than I should be using on this puzzle, watch the first number and watch what happens to that 3. When it becomes a 4, it turns yellow. When it turns yellow, that means you're using too many blocks. That means you could use fewer blocks to solve this puzzle. And as we just saw, we can solve this puzzle in 3 blocks, no sweat. There's the repeat block, there's the move forward block, and we already saw we solved the puzzle in 3 blocks, and that's exactly the right number to use. So that's our third big idea in computer science. What is code efficiency? Code efficiency means using as few blocks as possible to solve each puzzle. And remember, you've got that little scoreboard right there up at the top center of every puzzle to tell you how you're doing. And if you use too many blocks, that first number will turn yellow. So look for a more efficient way to solve the puzzle if that happens as you're going along. All right, very good. You know what? I think we're just about ready, but there's one more thing we want to do before we go any farther. So stay with me here in the live stream for a second. It is time for our contest break. we have a contest tonight, and we're going to give away something pretty cool. Julie, tell us what we're going to be doing on the contest and how this all works.
Absolutely. So tonight live, we are going to raffle off a license to Dash's Neighborhood. Entering this contest is super simple, but we do need an adult or a parent or somebody to help out with this and provide us with an email so that we can follow up with you if you win. Everyone who enters is also going to get a nice little surprise to their inbox. And here is our link. It is bit.ly/FCN robot. And that should take you over to a form where adults will need you to enter your name and your email. If you could tell us what school you went to, we would love to hear from you. And the comments are optional, but anything you'd like to share with us, we'd love to know.
Fantastic. And Julie, can you drop that URL in the chat so people can just click on it over there?
Absolutely. I will do that right now.
Super. By the way, I might mention Dash's Neighborhood. It's contributed to our Family Code Night, National Family Code Night puzzles by Wonder Workshop. They're the folks who make the Dash robot and Dash's Neighborhood. We really appreciate their support. We do lots of work with them. They're a terrific outfit. And the Dash robot is a lot of fun, and Dash's Neighborhood is a lot of fun. One other very cool thing about Dash's Neighborhood, by the way, it uses the same programming language we're using tonight to make Dash move around. That is, you'll be using Blockly, whether you're programming the Dash robot or the virtual robot in Dash's Neighborhood. So Blockly is a pretty neat programming language. You can do a lot of things with it, including control Dash the robot. So we hope everybody can go over and enter the contest. Take a minute, and again, any comments you have, we'd love to get from you, and enter the contest. And we are going to draw a live winner before the night's over. So that's what we're going to do right now. And then when you get done entering the contest, we'd like you to keep on going and do puzzles number 7 through 9. Puzzle number 9 is pretty tricky sometimes. So I'm going to come back and we're all going to do puzzle number 9 together. Pretty simple once you get the trick of it. And so we'll do that together. But for the moment, jump over there and make sure you get into the contest. bit.ly/FCN robot, stands for Family Code Night Robot, of course. And we hope you win. Good luck, everybody, and get those entries in. Then go to puzzle 7 through 9. See you in just a couple minutes at puzzle number 9, everybody. All right, everybody. I hope you got your contest entries in. I hope you finished puzzles 7 and 8. I know we had a couple of speed demons who are up there on puzzle number 10 or 12 or 15 or something. I'm sure you guys are doing great. But now I'd like everybody to come back. Let's look at puzzle number 9 all together. If we're going too fast or too slow, let us know. We can always do some adjusting. Puzzle number 9 can be confusing because of this big gray block here. You can't get rid of the gray block. When a block is gray, that means you can't delete it, the directions say. Well, that can be a little tricky. Let's look at what our situation is here. Maybe we can still figure out how to solve this. Here's our bird right here, and our bird has got to go forward a couple of spaces. Then again, from the bird's angle, from the bird's perspective, he's gonna have to turn right, and then he's gonna have to go forward a couple more blocks. And then even though it looks like a left turn for us, for him, it's going to be a right turn again because he's pointing down. And so he'll turn right, and then he'll head over here and get to the pig. That's quite a ways. But look over here, he only has 5 blocks to solve the whole puzzle, and we've already used 2. It means we get 3 more blocks. Well, sometimes when you're solving these puzzles, you're going to find that it's very useful if you think about the solution in terms of patterns. What pattern of blocks can we use and repeat in order to solve the puzzle? And in this case, we already saw what the pattern is. We know he has to move forward once and move forward twice and turn right. We know he has to do that first. So let's just pull out those 3 blocks and see what it looks like. There's a move forward, there's a move forward, and there's a turn right block. Well, that's fine. But now look, we've used 5 blocks and we only get 5 blocks to solve our puzzle. So we're out of blocks. That's the beauty of the repeat loop, because you can put more than 1 block inside of it. And so the reason I mentioned patterns and how important patterns are, and this is true in all kinds of coding, you want to figure out a pattern that you can repeat to write more efficient code. That is to solve the puzzle in as few blocks as possible. And this is a perfect example of how to do that, because I'm going to drag all 3 of these blocks and stick them inside the repeat loop. Now, think about the pattern and think about repeating the whole pattern 3 times. What's going to happen? He's going to move forward, turn right, move forward, turn right, move forward, turn right. It's like a dance step. He's going to do it 3 times. And sure enough, if you look at him, he's going to go move forward, turn right. He'll be pointing down. Move forward, turn right. He'll be pointing to over toward the pig. Move forward, and he's going to get that pig. So in just 3 blocks, we're able to get the pig all the way over there through the power of the repeat loop. And so if we run this, you'll see it's going to work perfectly, I think. There you go, move forward. Okay, that's 1 time. That's 2 times. Bingo. All right, 2 more things I want to show you real quick. I've been telling you you're writing code tonight, and here's the proof. There's a little button on each congratulations window that pops up after each puzzle that says show code. Let's click on that and see what happens. Well, look at this. You know what that is? That's JavaScript. JavaScript is one of the most powerful and popular programming languages in the entire world. It turns out that every block that you use in Blockly represents a line of JavaScript. And so when you stack up the Blockly blocks, you're actually stacking up JavaScript commands. There are 2 kinds of programming languages that people talk about. There are block-based programming languages like Blockly that we're using tonight. And then there are character-based programming languages. And characters are like letters or numbers that you type out, you know, A, B, C, D, whatever it is. And you can see down here, JavaScript is a character-based programming language. And that means you have to write with the keyboard, the full text of each command that you're using. And that's what character-based languages make you do. They're also much more powerful. You can do tons of things with JavaScript. It's an amazingly powerful program. And Blockly is a little simpler, not as powerful, but a lot easier to use. So Blockly is a great place to start, and you're really writing JavaScript. So I said you were writing real code, you're writing real code. And now, before we go any farther, I just want to show you one more thing. There's a very cool new capability in this next puzzle. You know, we've learned about the repeat block, which is very cool. Well, now we have an even smarter kind of repeat block. Now we have a block that's smart enough where you don't have to tell it how many times to repeat, because the block will repeat forever until it reaches its goal. The repeat until, and it will repeat whatever block or blocks you put inside forever until it gets to the pig. So that's a more powerful block for you. And now I think you're ready to go do the next few puzzles. Do puzzles 9 through 13, and I'll come back. We'll learn our next 2 big ideas about computer science. And then after that, we'll be coming down the home stretch and heading towards that little prize drawing that we're looking forward to. So everybody hang in there, keep on going, 9 through 13. Again, let Julie know what puzzle you're on. And Julie, keep me posted if we're too far ahead or behind, and we'll see everybody at puzzle number 13. All right, everybody, come on back to the live stream. We're going to learn our next couple big ideas about computer science and talk about a couple more interesting things here. So come on back. And now, I like this big idea. This one's pretty good. There are no mistakes in coding. I'll tell you, one of the most important things to learn in computational thinking and coding and trying to think like a programmer is that programmers make little errors all the time, but it's not really a mistake. It's not, you're not going to break anything. The key idea here is go ahead and try stuff, see what works. You can make little errors all the time and it doesn't matter. It's just how you make your code better and better. So if your code isn't quite efficient, it's not really a mistake. You just haven't quite made it as good as it can be yet. Well, the truth is that's what programmers do all the time. Most of the time, what they're doing is fixing those little errors in their code. And in fact, there's even a name for it. It's so common. It's called, the little errors are called bugs, and fixing them is called debugging. And so when you debug code, you just go through and you find the layers and make them better and better. And it's just all part of making your work be as good as it possibly can. It's all part of the process. And so there aren't mistakes. You can't really do anything particularly wrong. You just, keep trying, persevere, as they say, get better and better at it, do a better job each time. It's all part of the process. And don't worry about making little mistakes or errors. It's just part of the process. And I think you'll have a good time if you think about it that way. Let me show you how to make a mistake in code. That's a pretty easy one here. Now we're going to move on to a new kind of puzzles. And now we're here at puzzle number 13. And I kind of like this one. We're on to plants versus zombies, right? So we have this zombie right here. And if he goes forward, he's going to get eaten by that plant. That is not good if you're a zombie. What you have to do is he has to come all the way down here and make it all the way down these steps here until he gets all the way to the sunflower. That's what he wants. Well, we're going to use this repeat until block that we learned about last time, and we're going to figure out what pattern of blocks do we stick inside the repeat until sunflower block that'll help our zombie get all the way down there. Now, let's say that I made a mistake and I came out here and I decided to, instead of, see what I'm going to have to do, I've got to get down here and then keep on going down these stairs, right? But let's say that I made a mistake and I told him to go forward and then told him to turn right. Let's see if we can get this in here. There we go. Now, see if he moves forward and then turns right. Now, what's that going to do? Well, let's run our code and see what happens, okay? So watch what happens to our zombie here. We'll see if there's any problem in my code. Oh, tough break. Our zombie just got eaten by a plant. Well, I guess there was a bug in my code, huh? And bugs are actually kind of fun. You can do all kinds of crazy things with bugs. Here, you want to see my zombie dance forever? I'm going to make him turn right. Well, I'm going to reset the puzzle and go back to the beginning. I'm going to take a turn right block. Now, turn right until you get to the sunflower. How long do you think he's going to turn right for? You're right. He's going to turn right forever. There he goes. Because he's been coded to repeat that command until he gets to the sunflower. And unfortunately, turning right is not helping him get to the sunflower. It's keeping him right in one place, spinning like a top. And I think we're going to have an extremely dizzy zombie on our hands in just a second. I'm going to go ahead and reset, stop. And now, of course, the right way to solve this puzzle is to think about the pattern. What's the pattern that's going to get our zombie on the right track? Well, if he goes forward, we already found out he gets eaten. So the first thing he really has to do is turn right. And then he'll be pointing down and we can move forward. That'll be good. Again, we're thinking about the pattern that we want him to repeat over and over again until he gets to the sunflower. And these 4 blocks, let's look at what that's going to have him do. Turn right, move forward, turn left, and move forward. Again, think about the pattern you want to repeat over and over again. And sure enough, there's a pattern to repeat over and over again to solve this puzzle. We want him to go down and over and down and over and down and over, all the way down. And it turns out to make him go down and over, it's exactly what we have here. Turn right, move forward, turn left, move forward. As I run this code, watch each block turn yellow because you can watch your code execute as it runs. And so as he works his way down the stairs, you can watch our pattern repeat over and over again until finally he gets down to the sunflower. Let's see if we've solved it correctly this time. Right, forward, left, forward. There he goes. There's another time. And that sunflower could be a million steps down and he would make it right on time. Perfect. All right. So I do love that one about no mistakes in coding. Kids, be fearless. Just go ahead, push the run button, see what happens. All you can do is find a little bug and you'll fix it. And you'll get better and better as a coder. That's the whole idea. This brings us to our 5th big idea in computer science. I like this one quite a bit too. This one sounds technical. It sounds difficult. What is a conditional? Kind of a big word. It's actually really easy. You guys use conditionals every day. What's a conditional? Well, a conditional is called an if-then statement. And it's just the way our minds work. If it's cold, then I put on a sweater. If I'm hungry, then I have something to eat. If someone is nice to me, then I say thank you. If then. It's just a basic part of logic and part of how we think. And it turns out it's also part of how code works. Let me show you how it works in puzzle number 14. So here we are in puzzle number 14, and it introduces this idea of the conditional, of the if-then statement you can put in your code. And you can see that this would make your code a lot smarter. Here we've used 4 blocks already. We only get 5, so we only got 1 more block. And you can see we have gray blocks here that we can't remove, including this new if-then block. Okay, that's the conditional block right there. And you can see that it is down here at the bottom of our stack, right down here. And so you can see where that block is in your lineup of blocks down here. If there's a path to the left, then what do you want to do? Now, one nice thing about this is we can see what the zombie has to do. Here he is right here, and he's going to go forward. If he turns right, he's going to come down here and get eaten by the plant. So we don't want that. And look, right up here, that's his sunflower. That's what he's after. So the directions are use the new if block to let me decide when to turn. That's how smart your code is going to be. It's going to know how to make a decision on its own. So we only need one more block, but we have to think about what block it's going to be. And of course, that one more block is going to go right in here. All right, let's think about the logic here. Here's our zombie, and this is our code, and it will repeat these commands forever until it gets the sunflower. And the first thing it's going to repeat is the move forward block right here. Okay, that's great. So our zombie's going to move forward. He's going to move forward again. But now look, if he keeps trying to move forward here, he's going to bonk right into this wall, right? And we don't want him to turn right because he'll go down here and get eaten by the zombie. So we want him to turn left. But how will he know whether he can turn left? Because we've programmed him with a conditional. And the conditional is if there's a path to the left, what do we want him to do? Well, you can see if he comes up here and there's a path to the left, we want him to turn left. Exactly right. And so now we've used all 5 blocks and we have to get all the way to the sunflower. And I think we're going to make it just fine. You'll see every step the zombie goes, he's asking himself, is there a path to the left? And he shoots a little white ray off to the left to see. And so every step of the way, he has to obey our command if it's relevant. If there is a path to the left, then he has to turn left. That's the conditional that we put into the code. And so as he goes along, watch, he'll shoot that little white ray off to ask. And anytime there is a path to the left, he has to turn left. Unfortunately, that's going to let us solve this puzzle. So let's let her rip and see what happens. And there's the little white ray. Nope, no path to the left. Oh, path to the left, so he turns. But now all the way up here, there's no path to the left, so he just keeps on moving forward, and he gets his sunflower. Good deal. So that is our 5th big idea in computer science. What is a conditional? You guys are just doing great. We're coming down the home stretch here. We have a few more minutes to go. I'd like you to go and do puzzles 14 through 17. And by the way, don't worry if you don't finish all the puzzles. I'm going to show you a couple of tricks at the end. They'll help you finish no matter what. Do puzzles 14 through 17. We'll come back. We'll learn our last big idea about computer science, and we'll move into a couple other things to wrap up tonight's program. Julie, has everybody entered the contest? Should we give them one more tip to enter? Do we have time for it?
I was just going to say that. I was going to say final call, everyone. I see that many of you have entered. Good
Wonderful.
luck, everybody.
Wonderful.
But yeah, last call. We are going to draw the winner live tonight. And I need a little bit of time to collect everyone's entries and use our random number generator and like do this right so we can truly pull a winner from tonight's audience. So get those entries in, and good luck on your puzzles as well.
Excellent. Well done. And you'll see the prize entry code there in the chat area. I'm sure Julie's dropped that in. It's bit.ly, FCN robot, I believe. In any case, I'm sure the link is in chat. So if you haven't entered, go ahead and enter. Julie will be drawing our winner in just a minute. I'll see you at puzzle number 18 for our last big idea in computer science and to wrap things up here tonight. So see you in just a couple minutes, everybody. All right, everybody, come on back to the live stream. We are coming down the home stretch. Now, don't worry if you aren't all the way to puzzle number 18, or if you've gone beyond number 18, don't worry about it. We're going to show you how you can take your time and do this at any speed you want. But we are coming down the home stretch. We just have a couple minutes left. So what I'd like to do is give you a couple tips about puzzle number 18, and also learn our last big idea, our sixth big idea about computer science. So down here, we have introduced a brand new block, and we learned about the conditional block a minute ago. If, then. That's the conditional, right? Now we're learning a new block that's even more powerful, and it's called an if-else statement. So it's not just if it's cold outside, put on a sweater, or if there's a path to the left, turn left. It's if-else. So that's much more subtle, and it lets the code be even smarter. So it might be if there's a path to the left, turn left. Else, if there's not a path to the left, go straight or turn right. It can be whatever the command wants to be, but it's if and else. So it's if one thing, do this, and otherwise, else, do something else. And puzzle number 18 really shows a nice example of this. Here, we're using characters from the movie Ice Age. And as you may remember, there's a really fun little character named Scrat, this little guy right here. And what does Scrat like more than anything in the world? He loves acorns. He's crazy about acorns. So Scrat has to go straight and then take a left and come up here and then take a left again and make it all the way down here and not take any of these wrong turns and make it all the way to the acorn. And then he's going to be one happy little Scrat. And he has 5 blocks to do it. We already have one in place. Well, I know one thing. We're going to have to figure out a pattern that we can repeat over and over again and stick it inside the repeat block. So we'll take out the repeat until block. We know that's going to work for us. And then there's our new if else conditional. So we can take this out, and what do we want Scrat to repeat forever? Well, it's this pattern of blocks around the if else conditional. If there's a path ahead, we want him to do one thing, and if there's not a path ahead, else, we want him to do something else. Well, let's look at Scrat. So the first thing, if there's a path ahead, what do you think you want him to do? Right? Pretty easy. We want him to move forward. So let's put a move forward block in there, and you can see what's going to happen. He's going to move forward, and then if there's a path ahead, well, there is no path ahead here. So what's he going to do? That's when the else kicks in. If there's not a path ahead, then else. Otherwise, what do we want him to do? Well, you can see we want him to turn left so he can continue on his way. So we'll take the turn left block and stick it right in there in the else opening. Well, you know what? We've just used all our blocks. We've used 5 blocks. Have we solved the puzzle? The way you find out that, we could run it, but also just put yourself in Scrat's position and follow the commands in your mind. So repeat until acorn. If there's a path ahead, move forward. Okay, he's going to move forward. Else, there's no path forward right here, turn left. So he's going to turn left. And then if there's a path ahead, move forward, he'll be pointing up. Sure enough, there'll be a path forward. He's going to go forward. There's a path forward. He's going to keep going. He's going to keep going. But anytime there is not a path forward, what's he going to do? He's going to follow our else command, and he's going to turn left. Now, when he's coming down here, how do we know he's not going to take a left down into this little dead end right here? Why? Because the first part of the if-else conditional is if there's a path ahead, move forward. And so that's the first command he's going to follow forever. And so he won't take this wrong turn here or this wrong turn here, because the first part of the if-else conditional is if there's a path ahead, move forward. So let's run our code and see if he gets his acorn. I think he will. Let's go. And you can see he's shooting off his little ray forward this time to see if there's a path forward, because anytime there's a path forward, he has to go forward. And he's going to get his acorn. And he's going to be one happy Scrat. All right, everybody. Now, we haven't quite got to puzzle number 20, but we are going to wrap up the puzzles right now. And I just want to tell you, I want to recommend everybody go ahead and finish puzzle number 19 and 20 later, or if you haven't already, because there's a really nice surprise from code.org for you at the end of puzzle 20. So we recommend that very highly. So we hope you all have enjoyed learning all these 6 big ideas about computer science. Hope you've enjoyed it. Hope you want to do more. That's the whole idea. Computer science, coding, it's just play. And it's a really fun kind of play, and you get more and more power and more creative as you go. It's just a wonderful thing to learn. So how can you learn more after tonight? Well, first of all, I mentioned just a second ago, I'd like you to make sure you finish the puzzles. You can go back to familycodenight.org anytime, click on that start button. And as you may have seen, you can jump to any puzzle you want just by clicking the dot up at the top. So I'm going to go to puzzle number 4 by clicking on puzzle number 4. So you can go back to whatever puzzle you're on and keep doing these puzzles. And again, you'll be taken puzzle by puzzle through the whole program. And if you want to, you can go all the way to puzzle number 20. Wherever you want to go, come back here and finish the puzzles. And as I mentioned, do finish puzzle number 20. It's pretty fun. Second, we're going to send everybody who enters the contest tonight our big ideas summary. You learned 6 big ideas tonight about code efficiency and about conditionals and about what is a program. And we're going to send you this little summary of what you learned tonight. We hope you enjoy that. And remember, these ideas are common to almost every programming language you're going to learn in your whole life. So it's great. If this is your very first hour of coding, fantastic. Good job. You're learning really important ideas that you'll use in lots of other situations. Also, we're going to send everybody who signed up for the contest tonight your own Code at Home family pack. And this is full of free games and resources for learning about coding online. And there's one even for a very advanced kind of coding for JavaScript that we saw a little sample of when we saw the show code button tonight. It's called Grasshopper. It's created by Google, and it's a self-paced series of puzzles, kind of like our puzzles tonight, that will teach you about JavaScript. So it's a pretty advanced program. It's called Grasshopper. That and lots of other free online coding learning resources and play and games are all listed here in the Code at Home family pack. So that's one other thing we're going to give to everybody tonight. Also, everybody gets a badge. Everybody likes badges. Well, here's your badge. We did National Family Code Night. Congratulations, everybody. I hope you had a good time. And if you want to take this badge and post it on your social media, post it with a hashtag of Family Code Night, it'd be great. You know, spread the word, try and encourage other folks to have a Family Code Night experience at their school or even on their own. And you can sort of spread the word through your badge. Also, one more thing that we'd love to invite everybody to do, it's selfie time. So what we love to do is get photos of you guys as you're finishing up your Family Code Night. And we use these in our videos and on our website. And you can see here in our National Family Code Night celebration video, we love all our families and how much fun they have out there. So if you can, take a minute right now, take a little selfie of yourselves, of you and your kid in front of the computer or anywhere you like. You can be as goofy as you want. You can be as serious as you want, and send us your selfie. And just so you understand, these will be public. And so we post them on the website. So don't send anything you don't want to see in public. But if you want to take a selfie and be featured in some of our stuff in the future, we pick photos from those that get sent in. We'd love to include yours in that as well. So it's selfie time. Take a quick picture of yourselves and email it to us at info@csiselementary.org. And that's the name of our organization, csiselementary.org. So take a selfie, shoot it into us at info@cselementary.org. We hope you had a great time tonight. I mentioned cselementary.org. This is our organization, and we help schools build and get recognition for their computer science programs. We do 4 different kinds of family code nights. Tonight's was on coding. We have another one on cybersecurity, how to stay safe online. We have another one on artificial intelligence. It's surrounding our kids. Kids need to understand what artificial intelligence is about. And this is really a fun course, a fun way to learn about it. And then on creative computing, which is learning about Scratch, especially for older kids, learning about programming in Scratch. So we're always building our Family Code Night programs and adding more and more to it. We want to help families learn about computer science and coding and computational thinking, and that's one way we do it. Another thing we do, we have Code 5 courses. These are 10 lesson courses that any school can have for free, where we get a great teacher who can be a virtual co-teacher for any teacher in your school. So your teachers don't have to have computer science experience. They can use our Code 5 courses. The teacher in the classroom can manage the experience and kind of learn along with the kids and have a lot of fun. And our classes go in 10 lessons and teach different kinds of aspects of coding and computer science and artificial intelligence. And those are all free. And I'll show you in just a second where you can find those. And then finally, for schools that already teach computer science, we have a first mover goals program where you can post your goals for your school. And on our national map of every school in your state, your school will get a pop-up that shows your goals in computer science. We're trying to encourage every school to teach computer science to all its kids and to help them do so. And we want to give recognition to the schools that are already doing that. So that's our movement. That's what we're trying to build nationally at every school. And really, it's a movement that starts with you, because as a parent, as an educator, you can make this happen at your school. And in fact, there's a little tab right here on our homepage that says parents. Parents, please click on that. You'll see a very simple little note you can send to your principal and say, hey, let's do more of this kind of stuff. And we'd love to have your support. This is a movement that starts in every school. It doesn't start in Washington, in your state capital, or even in your district. It starts with you. It starts in the grassroots of every school. So we welcome you, and we hope you'll be involved with us. And we really look forward to working with you and look forward to your suggestions. So we're very much a grassroots movement. We started as a family activity at one elementary school in California, and now thousands of schools all over the country have done family code nights and are working with us in various other programs. So welcome to CS Elementary. We hope you can get involved. I mentioned the Code 5 courses. They're all available free at Pathfinders Online Institute. There's a URL right here, bit.ly/infosys/code -code 5. That's where you can find the Pathfinders Online Institute, or just Google it. And that's where you can get all those Code 5 courses. You stream them for free from the Pathfinders website. So we urge you to do that. Just look for Pathfinders Online Institute for our free Code 5 courses and lots of other great resources. We also do various Code 5 live events, and by getting yourself on our email list, we'll let you know when those live events are coming. We just recently did a coding robotics club led by a high school junior, a girl from Austin, Texas, who led a bunch of kids from all over the country in a robotics club, and it was really a lot of fun. So join our email list. We'll keep you posted on our next Code 5 live events and all kinds of fun stuff coming up. I mentioned that schools post goals. When they do, they get a pop-up on our schools map. It looks like this. It gives your school recognition for the great work you're doing in your school too. So that's about it. I think we have one more thing we should deal with. Julie, what else should we do tonight? Any ideas?
Oh, yeah. Sorry, I have one idea.
Okay.
One little idea. Maybe have like a little contest winner to announce
Oh,
here.
a contest. Well, that's a great idea.
Everyone loves a good contest, right? And thank you guys all for your entries. I just wanted to reiterate all the links that John talked about with Pathfinders and all this will be in your Code at Home pack. So everyone who entered the contest, or even if you forgot to enter the contest, it's worthwhile to enter the contest because you still win. Everybody wins. But tonight's winner of the Dashes Neighborhood license, yes, a drum roll please, is Alicia De Alba from Greenwood Intermediate.
Wow, Alicia De Alba from Greenwood Intermediate, congratulations. You are going to get a license to Dash's Neighborhood. You're really going to enjoy it. You'll use Blockly, you'll program a virtual Dash. It's pretty cool. I think you're going to enjoy it a lot. Fantastic. All right, everybody. Well, Alicia, congratulations. For the rest of you, sorry you didn't win, but you are going to get a bunch of great stuff. Code on. Ask your teachers at school and your principal to bring more coding to your school. As I said, we have year-round family code nights. Your school can sign up for these programs all year long to learn all kinds of things. We love doing them with you. We love seeing you guys here at our family code nights. So I hope we'll see you at another one soon. And I guess that's about it for tonight. Code on, everybody. Have fun. Be creative. Be powerful. And thanks for coming. So great to see everybody. We'll see you next time. Julie, thanks so much for your help tonight, as always.
Thank you, John. And thank you, everyone who was chatting along. You really made it such a wonderful night. And code on.
Good deal. See you later, everybody. See you next time.